Hello guys, this is Wits Lounge Learning Made Easy, and in today's video we are going to be studying the relationship between mass and volume, mass and number of particles, volume and number of particles, and finally the relationship between number of moles and concentration. Do note that the link to other studies in stoichiometry will be found in the description of this video. We've established three major things or three major relationships. We have that N is equals mass over molar mass. We also have that N is equals volume in cm cube all over 22,400 cm cube per mole. And then we have that N is equals volume in dm cube all over 22.4 dm cube per mole. And finally, we would have that number of moles is equals number of particles all over 6.02 times 10 raised to power 23. Now, these relations are relations of the different particles or quantities of measurement to number of moles. Let's see. If I have that x is equals A and this same x is equals B, it simply means that B is equals A. Now, why did I make this statement? If you look at the board, you will notice that N is equals volume in cm cube all over 22,400, and this same number of moles is equals mass over molar mass. What can we establish from that? We can actually equate the mass over molar mass to the volume in cm cube all over 22,400 cm cube per mole. Why? Because they are both N values. Hence, we have seen that we can establish a relationship between mass and volume as mass over molar mass equals volume in cm cube all over 22,400. So I'm giving you straightforward formulas to relate these things. This particular relation relates mass and volume in cm cube, and I think you can try it out. Try relating the mass to number of particles. Yes, and that's quite simple. What is it going to be? Mass over molar mass will now be equals everything about the number of particles in relation to number of moles is going to be number of particles divided by 6.02 times 10 raised to power 23, and so on and so forth. So let's get to solve questions with respect to these relations just established. Let's start with the first one. We established that the relationship between mass and volume is going to be equals mass over molar mass equals volume in cm cube all over 22,400 cm cube per mole, or mass over molar mass equals volume in dm cube all over 22.4 dm cube per mole. So let's solve the question. Calculate the mass of chlorine gas which occupies a volume of 1.12 dm cube at STP. This is actually going to be quite simple to solve. So let's look at that. Now, in this question, you are asked to find the mass, whereas you are given the volume in dm cube. So which of these relations is the relationship between mass and volume in dm cube? Yes, you will notice that it is the second one, which is this one. So we are going to be using this formula. We are asked to find the mass, whereas we are given the volume in dm cube. We relate it with this formula. So let's look at the parameters given. We have that the mass is what we are looking for. The molar mass of chlorine gas is going to be equals atomic mass multiplied by atomicity. This is actually one of the things that we established in the earlier video, so please try to look them up. The atomic mass of chlorine gas is 35.5. and the atomicity of chlorine gas is 2. Gaseous elements exist as the atomic molecule, so which means that the molar mass of chlorine gas is going to be equal 71 gram per mole. We have that. Okay, the volume in dm cube as given in this question is equals 1.12 dm cube. Let me try to separate that. Okay, so with that said, let's get to solve. Now, the relationship we are going to be using is mass over molar mass equals volume in dm cube all over 22.4. That is going to be equals, the mass is what we are looking for. The molar mass of the gas is equals 71 as we found here, and it is equals the volume in dm cube is 1.12 divided by 22.4. If we make m the subject of formula, we are going to have m equals 1.12 multiplied by 71 all divided by 22.4. Eventually, after doing this calculation, the mass is going to be equals 3.55 grams. And you have that. Quite simple. the relationship between the mass and the volume is established by that direct formula. Now, you do not need to cram these formulas. What I want you to do is solve questions with them. And as you solve as many questions as possible, you will notice that these things would actually remain in head. Okay, so let's go to the next relation. The next relation we are going to be establishing is the relationship between mass to number of particles. And that is going to be expressed as mass all over molar mass equals number of particles, in this case molecules, divided by 6.02 times 10 raised to the power 23. Mind you, m is equals mass, mm is equals molar mass. So with this said, let's actually solve a question to help you understand this. What is the number of molecules contained in 20 grams of sodium hydroxide? So let's get to solve. Now, first of all, let's establish the quantities given. We have that the mass given in the question is 20 grams. The molar mass of sodium hydroxide is equals, that's 23 plus oxygen is 16 plus hydrogen is 1, and that is going to give us 40 grams per mole. And then we have that we are looking for the number of molecules. So you find out that because we are looking for the number of molecules, we need to make it the Stoichiometry formula, and then we would have that the number of molecules, let's solve on that side, number of molecules, the mass is 20 grams divided by the molar mass, which is 40 grams per mole, is equals number of molecules divided by 6.02 times 10 raised to the power 23. So if we happen to cross multiply, we are going to have number of molecules equals 20 times 6.02 times 10 raised to the power 23, all divided by 40. If you cancel out, this is going to be 1, this is going to be 2. Cancel out 1, this is going to be 3.01. So eventually, the number of molecules of sodium hydroxide contained in 20 grams will now be 3.01 times 10 raised to the power 23. Sorry. Will now be 3.01 times 10 raised to the power 23 molecules. And you notice that very simple. So you have that this is actually a straightforward formula that can help you relate mass directly to number of particles very easily. So remember, all you need to do is solve more questions with respect to that, and then you have that these things will remain in your head. We go to the next one. The next relation we are going to be establishing is the relationship between volume and number of particles, and that is going to be expressed as volume all over molar volume equals number of particles all over 6.02 times 10 raised to the power 23. So in a scenario where the volume is in cm cube, it will be volume in cm cube, the molar volume in cm cube is going to be 22,400 cm cube per mole equals number of particles all over 6.02 times 10 raised to the power 23. But if your volume is in dm cube, it is going to be equals volume in dm cube all over 22.4 dm cube per mole equals number of particles divided by 6.02 times 10 raised to the power 23. To understand this relation, we are going to be looking at this question. What is the number of molecules contained in 1.12 dm cube of chlorine gas? So let's solve this. Now, you would have that because you are asked to find the number of molecules and you are given volume, it's going to be a volume to number of particle relation. And then the volume is in dm cube, so it's going to be volume in dm cube divided by 22.4 equals number of molecules divided by 6.02 times 10 raised to the power 23. So please do not get it confused. When I say number of particles, I also mean number of molecules. So have that in mind. Good. So with that said, let's get to solve this. Now, I was given the volume in dm cube as 1.12 dm cube. I was given my number of particles. No, I was not given my number of molecules we're looking for that, and because of that we get to solve. So straight up, what's going to be our solution? Now the volume in dm cube is equals 1.12 dm cube divided by, notice I'm just putting the values in place, by 22.4, which is going to give us the number of molecules which we don't know, divided by 6.02 times 10 raised to the power 23. So what do we do here? We cross multiply. Now cross multiplying, this implies that we're going to have number of molecules being the subject of formula. We are going to have 1.12 times 6.02 times 10 raised to the power 23, all divided by 22.4. If this happens, what are we going to have? Our answer is going to be 3.01 times 10 raised to the power 22 molecules. So you have that whenever you are relating the volume to number of molecules, or ask to find the volume when you are given number of molecules, or the other way around, where you have the volume and you are asked to find the number of molecules. What do you have? You simply do this. The number of molecules is equals the volume in dm cube with this particular formula. With that understood, we will come to the final part, which is the relationship between number of moles and molar concentration. That relationship is simply given by number of moles equals molar concentration multiplied by volume. Now, if I'm to represent it symbolically, it's going to be N equals, molar concentration is represented by the symbol C multiplied by volume. Now, if the volume is in dm cube, this is actually what I get. But in a scenario where I have number of moles and the volume is in cm cube, it's going to be equals N is equals C multiplied by V in cm cube divided by 1000. Why this is gotten is because V in dm cube is equals V in cm cube over 1000. So when you do this, you are going to have this particular relationship established. Now, having said this, let's try out one question to help us understand this. What is the number of moles contained in 250 cm cube of a 0.5 mole per dm cube solution of hydrochloric acid? Now, if we look at the question, we were given the volume of the solution as well as the concentration, and we are asked to find the number of moles. Remember, the relationship between number of moles and concentration, molar concentration, is given as N equals molar concentration, which is represented by C, times V in cm cube divided by 1000, or number of moles equals molar concentration times V in dm cube. So try to memorize these things with your spare time so that it will be easy to understand. Now with that said, N is equals, we don't know. The concentration given in the question is 0.5. How do I know? The unit of concentration, molar concentration, is given as mole per dm cube. And then the volume of the solution is equals 250 cm cube, as we saw in the question. So which means that the number of moles is going to be equals, our molar concentration is 0.5 multiplied by the volume in cm cube, which is 250. And now, because we are relating the number of moles and volume in cm cube, we are going to be using this particular formula. So N is equals 0.5 times 250, all divided by 1000, and that is going to give us 0.125 moles. And that's that basically about the relationship between that. So reiterating, we have that the relationship between mass and number of moles is given as number of moles equals mass over molar mass. N is equals mass over molar mass. Where we have the relationship between number of moles and volume, number of moles is equals volume in dm cube all over 22.4, or volume in cm cube all over 22,400. Sorry about that. That's supposed to be 400. Okay, and then find the next one is number of moles and number of particles. N equals number of particles, or in this case molecules, all over 6.02 times 10 to the power 23. Then we have the mass to volume relation. The mass to volume relation is mass over molar mass equals volume in dm cube all over 22.4, or mass over molar mass equals volume in cm cube all over 22,400. Then we have the mass to number of particle relation, which is given as mass over molar mass equals number of particles divided by 6.02 times 10 raised to the power 23. And then we go to the relationship between volume and number of particles, given as volume in cm cube all over 22,400 equals number of particles, or in this case molecules, divided by 6.02 times 10 raised to the power 23, or volume in dm cube all over 22.4 equals number of molecules all over 6.02 times 10 raised to the power 23. Then we go to the relationship between number of moles and concentration. N is equals C multiplied by V in dm cube, or N is equals C multiplied by V in cm cube all over 1000. So please do memorize these particular relations and have them in head. Remember, this is Waits Loud, learning